First off, thanks a lot to the organizers for inviting me to this special AI in Finance virtual summit. It is a great pleasure to speak today about a journey towards algorithmic assurance of governing machine learning or AI systems at scale. I'm going to talk about some of the recent developments and perspectives, and we'll also share some of the lessons learned when attempting to scale AI applications, and with that, their business impact. And for that, I'm going to look at different angles. Big data and tech as the key enabler and foundation for all. Then the AI governance perspective from ML practitioner angle. And finally, and actually part of the other two, the perspective of sustainable growth in the light of AI adoption across the enterprise. So let's start with data, or should I say big data, and also big investments, as we can see, growth of roughly 40% in 4 years' time. When we look at the growth of data, it has a clearly exponential shape. The International Data Corporation, or the IDC, is expecting that we reach 59 zettabytes in the world by the end of the year, which is more than expected due to COVID and work from home enablement, and reaching roughly 175 zettabytes by 2025, which 65% will be generated by enterprises, where financial services obviously are taking a notable part. Over the next 3 years, it is forecasted that 46% of the worldwide GDP will be driven by products and service offerings by digitally powered enterprises. And 30% is going to be real-time data. And every person will have one digital touchpoint every 18 seconds. So you better use every touchpoint with your customer well. And well, obviously, with all this big data, there are also big opportunities. Again, the IDC is predicting a doubling in productivity over the next 5 years as a result of AI adoption, resulting in shorter reaction times to customer needs, faster product innovation cycles, and improved customer satisfaction. In their AI strategies view from earlier this year, they have presented the results of a large survey, identifying better customer experience as a key business driver for scaling AI, and IT automation as a highly relevant AI use case over the next 2 years. When looking at banking front to back, you find the demand for adaptive user experience, chatbots, financial assistants, personalized recommendations for products and investments, and of course, should be fast and easy. One interesting aspect when looking at the back is that these use cases are clear from a business view, but from an IT view, they are rather non-trivial. This is usually the case in a large and mature organization with massive and partially legacy IT infrastructure and core business systems that were really never designed for handling AI use cases at scale. So while with all that big data we get big opportunities, there are also big challenges. So what often happens is that you start with a business idea and a proof of concept, and sooner than later you end up in a black POC hole from where it seems pretty difficult to ever get to production, and thus to actually make a business impact. One of the most prominent bottlenecks is data integration and preparation and the non-harmonic coexistence of modern and legacy IT. The lesson learned here is that one needs to have a well thought through information architecture that supports the full data science lifecycle and thinking long term, a hybrid multi-cloud strategy. In this way, one can keep traditional business critical IT and private on-prem cloud for some sensitive applications, while fully leveraging the power of the public cloud providers and APIs with, for example, pre-trained models. AI applications can then follow a develop once, deploy anywhere approach, and together can accelerate a firm's digital transformation journey. But actually, with all these options out there, finding the right mix may become really non-trivial. For example, when thinking about using APIs with pre-trained AI models, depending on the in-house purpose of the model, the actual context that the public vendor model was trained on may become very relevant, also from a regulatory perspective. After all, what we are looking at is what most traditional IT functions are not very familiar with: how to manage software 2.0 or machine learning systems at scale. Reason being that when managing traditional software or 1.0, we're talking about explicit instructions to the computer with a desired behavior. While with machine learning systems, we give implicit instructions to optimize against a given target as our desired behavior. Well, one by now proven solution to handle this dynamics and uncertainty is the containerization of AI applications and their orchestration and governance using dedicated algorithms. These can sometimes be AI models themselves. While there are by now sophisticated administration tools, dashboards, and so on the market, a systematic upskilling of the IT workforce is still needed in a close collaboration with those that are using the platforms, the data science professionals. Well, on here you see all the benefits of algorithmic end-to-end container orchestration along the data science lifecycle. From ideation, data generation, exploration to model development, independent model validation by the risk function, testing, and finally, model deployment. Important here is also the ease of testing. For example, could have a few containers that are used for a subpopulation of the consumers to consider a new AI model version. Another element to highlight here as well is the full transparency when reconciling the impact of a model output, since both container and model codes are version controlled along the lifecycle. Okay, let's switch to another angle and look at AI governance. Here, let's first look at the origin, actually, of making AI governance a global topic of interest. It all starts with data generation process and the fact that we only have a glimpse of the real world out there in the data that is used to train our AI models, from which we then derive business decisions that affect again the real world. Only the fact that we are dealing with observational data or the lack of information can already induce some form of bias. Or that bias could be real and as a result of human judgment and maybe unconscious bias. The situation may become worse when the particular AI algorithm used actually amplifies that bias and may finally cause discrimination of customers. By now, there are many examples that hit the headlines, from lending, cards, law enforcement, HR, to education. While years were spent in optimizing model accuracy, now algorithmic fairness, and therefore trust, became really key when building AI applications. While it takes years to build a trustworthy brand, it can be really fast to lose it and likely never get that customer trust back. So as a result, policymakers have joined forces with the AI research community, making fairness and data ethics a primary topic of really every AI strategy out there. Meanwhile, many guidelines have been published which organizations can consider to derive their own internal AI principles and code of conduct. Here an example from the EU guidelines for trustworthy AI. But if you look at that, what do you do in practice? Well, in theory, we have a mathematical understanding of fairness conditions. For example, in here, let X be the features of a person on which basis we want to derive a business decision. And let A be a sensitive data attribute such as gender, race, or religion, which we clearly do not want to relate to our decision. Then a representation learning example would be to learn a new representation such that it removes the information correlated to the sensitive attribute A and preserves the information of X as much as possible. But in practice, it turns out to be a trade-off between model optimization, accuracy, and fairness, which has to be evaluated on a use case by use case basis. So over the last few years, many quantifiable solutions to deal with bias have been proposed, built, tested. Here an example that tries to formalize the treatment of different types of bias along the full data science lifecycle. Moreover, many methods along the ML/AI pipeline have been proposed over the last few years, from methods in data pre-processing, post-processing stages, to those that affect or modify your choice of training algorithms. Here are just two examples. Here's one, Adversarial Debiasing, which removes the bias from the learned Latin representations. And as you can see in this example, it uses two neural networks, where one finds, for example, the update of the weights, a hyperparameter noted here with alpha, that serves as an accuracy fairness trade-off. Another example is the debiasing variational autoencoder, which learns which inputs come from an underrepresented group and samples those more frequently during the training. Finally, on the sustainability note, I would like to add that the right corporate culture is key to build responsible AI products. Part of that is certainly to set out clear and simple guidelines. Here an example by Google. I would like to highlight the ask to diversify the workforce at every level and to make data science as transparent as possible, to make change management serious in order to foster adoption to a data-driven culture. And as a final remark, in order to really scale ML AI systems with a sustainable business impact in mind, one needs both an adaptive IT ecosystem with solid data management and virtualized distributed computing, as well as a transparent operationalization of fairness mechanisms that build trust in AI-powered services, both internally towards employees and, of course, the valuable customers. Thank you a lot for your attention.